In this lecture, we discuss about the convolution integral. In the previous lectures, I defined the convolution process with the concept of the convolution sum, and for the discrete time signals, the convolution of discrete time signals, we approach for convolution sum, and for the continuous time signals, we go for the approach of convolution integral. Okay, for the discrete time sequences we use the sum, and for the continuous time signals we go for the convolution integral. So let us see the convolution of two signals, and the formula was given. Let the two signals x of t and h of t are given, and the convolution of x of t and h of t is represented by let it be the output is y of t equal to x of t convolutions h of t, and this is integral minus infinity to infinity x of tau h of t minus tau d tau, and here the tau is the dummy variable. Okay, so by understanding the or by solving the problems, we can understand the convolution mechanism of the two signals. Okay, we start with the basic problem. Let consider a signal x of t, x1 of t, let be x of t, that is e power minus 2t u of t, and h of t is e power minus 4t u of t. So let us find the convolution between x and h. So before going for the convolution, let us draw the plots of this x of t and h of t. That is x of t plot e power minus 2t u of t. This one is an exponentially decaying signal starting from 0. E power minus 2t u of t, and for the same h of t also, this is also an e power minus 4t u of t, and this will be also exponentially decaying signal e power 4t and u of t. Both are exponentially decaying signals starting from origin t equal to 0. So according to the expression of the convolution, that is x convoluted by h, that is integral minus infinity to infinity x of tau h of t minus tau. So let us change the axis and the representation of these signals. X of tau equal to e power minus 2 tau u of tau, and h of tau, that is e power minus 4 tau u of tau. So we have dt. So here we have the signal x of tau and we have h of tau. So according to this expression, x of tau is ready, but we have to make x of t minus tau. So for the x of t minus tau, first we find out h of minus tau and then go for h of t minus tau. So that is the time folding of axis, like h of minus tau, and this will be like this, the tau axis, and this is 0. and this is h of minus tau. Now for this one I am adding t. For every tau value I am adding some integer small t. So this will become, the signal will be shifted to some position. Let it be, I am representing like this, that is, this is t. For the origin of 0 I am adding t. So let it be based on this t value, the signal may appear at the left hand side of this x axis or the right hand side of x axis. Okay, based on the value of the t, the signal will appear at any position of this x axis. So okay, don't bother about the why I am representing this signal in this negative time axis. Okay, so why I am representing like this means, in the integral, in the expression of the convolution, here the integral is represent, the integral limits are considered from minus infinity to plus infinity. That is, the signal should be multiplied in the range of minus infinity to infinity. So that's why I am considering, or I am assuming that I am moving this h of t minus tau signal from the minus infinity to plus infinity. Okay, so I am multiplying the x of tau and h of t minus tau for the different tau values. For that one, I will move this signal. From minus infinity to plus infinity. So let me draw the both signals. The signals are x of the h of t signal is like this one, t, and this is h of t minus tau. This is e power minus 4t u of t. So that is e power minus 4. So initially I am converted this one as into the tau axis. After time folding for it, I am adding t, that is t minus tau and u of t minus tau. This is the signal representation. And another signal, that is x of t. That x of t is like x of tau. This will be like this one. The both are the tau axis. So these two signals should be multiplied. By moving this h of t minus tau from minus infinity to plus infinity. So I will move this signal. Okay, I will move this h of t minus tau signal and multiply with x of tau at different positions of t. So if you observe this case, if you multiply these two positions, h of t minus tau multiplied with x of tau at this position, you will get the product, that is x of tau convolution of h of t minus tau, x of t and h of t, that is integral x of tau h of t minus tau d tau, and this will be 0 for t less than 0 until t touches the 0 value. Okay, until t touches the origin, until t touches the 0, there will be no product or no overlapping of h of tau and x of tau. So this is the case 1. So case 1, the product is y of t is 0 for t less than 0. Now I am sliding the h of t minus tau further, and consider in the case 2 the signal h of t minus tau, and this thing I am touching 0 and crossing the 0 value, okay, and crossing 0 value like this. One signal is like this and another will be like this, okay. So the result, the product of this one will be like and this is this one and another one is like this one. So now you have to identify this product, and this is t, this is 0 tau, and this is the multiplication of x of tau and h of t minus tau at this position, at a particular position, that is t, and the t is at a particular position of on the tau axis, okay. At this position the product will be like this. You have to calculate this one. So this will be moving towards the infinity, I mean towards tau equal to plus infinity. So your product y of t will be, okay, integral of the range of integration or the limits of integration will be 0 to t and x of tau h of t minus tau d tau. So this is x 0 to t, x of tau is, you know, that e power minus 2 tau, and h of t minus tau is e power minus 4 t minus tau d tau, and this is equal to, you can make this e power minus 4t, this is the integration with respect to tau. So let us bring this t outside of the integral and integral 0 to t and minus 2 tau plus 4 tau, this will be e power 2 tau d tau, okay. So let us do the integration, e power minus 4t, and the integral will be e power 2 tau by 2 0 to t, this will be equal to e power minus 2t minus e power minus 4t by 2, and this is the output holds for t greater than 0. So y of t is e power minus 2t minus e power minus 4t by 2 for t greater than or equal to 0 from the point of 0, okay, for t greater than or equal to 0. So this is the second case, and this valid for the next point till t touches the infinity. So that's why I am representing the condition for the t greater than 0, or else you can represent for e power minus 2t e power minus 4t by 2 and u of t, and this represents the t greater than 0. This is existing for positive t values. So for the consolidated output, that is y of t is 0 for t less than 0 and e power minus 2t minus e power minus 4t by 2 for t greater than or equal to 0, and this is the consolidated output of the convolution of x and h, okay. The convolution of e power minus 2t u of t and e power minus 4t u of t, okay. So you can take it as a standard reference, that is e power minus at u of t convolution with e power minus bt u of t. The output will be e power minus at minus e power minus bt by 2 for the t greater than 0, and for t less than 0 the output will be 0. Okay, so you can make it a standard expression to solve any problems quickly in the competitive examinations. Okay, right. Next, solve another problem, that is convolution of exponential signal and a step signal. Okay, so x of t e power minus 3t u of t and h of t u of t plus 3. Let's solve this one. So if you plot the signals perfectly at each and every case, you can solve the problem with a perfect answer. So let us plot this one for minus 3t, so minus 3t u of t, and this is u of t plus 3, the step signal starting from t equal to minus 3. Minus 3. Okay, so let us fold the signal. Okay, let us time fold the signal h of t. Okay, you can time fold the signals x of t also. So I want to make t minus tau as time fold. So let us first plot the time fold signal, that is h of minus tau, that will be like this. So plus this is origin, this is minus tau signal, and if you go for the time shift, that is h of t minus tau, let it be represented as like this. Okay, for the 3 I am adding t. Okay, for the 3 I am adding t, so this will be t plus 3, this point will be. So we have the points like origin and t plus 3 importantly. So let us concentrate on those 2 points. So let us plot one by one. So this signal, one is exponentially decaying signal in the right side, tau e power minus 3 tau u of tau, and another one is h of t minus tau, that is presented by like this. So t plus 3. So at this position there is no overlap. Okay, at this situation or at this t plus 3 value or at this particular t value, there is no overlap. Now I will slide the signal towards the right side. Okay, moving towards 0. Okay, moving towards 0. So till t plus 3 touches 0, the overlap is 0. So that is, so case 1, y of t is 0 for t plus 3 less than 0, that is for t less than minus 3, right? Am I correct? Right, t less than minus 3, the product is 0. Okay, that is till the t plus 3 touches 0 origin, the product is 0. After the t plus 3 crossing the origin, there will be some overlap. That is, let us see that case 2. Okay, both are infinite signals. Okay, both are infinite time signals. One is moving towards the positive time axis and another one is moving to the negative time axis. Okay. So let us plot those two signals. So one is, let us overlap both of them. One signal is like this, and another signal is like this, moving like this. It crossed the zero origin. It crossed the origin. Now there is some overlap. Let us find that one. Okay. So for t plus 3 greater than 0, let us find the expression for that one. So this is the multiplication of x of t, so x of tau multiplied with h of t minus tau. So y of t equal to integral, the overlap is in between 0 and t plus 3, and one expression x of tau is e power minus 3 tau, and another one is 1. Okay, and this is e power minus 3 tau by minus 3, 0 to t plus 3. Okay. So this is, if you make it as e power minus 3 t plus 3 minus 1 by minus 3. So this is 1 minus e power minus 3 t plus 3 by 3. So this is for t plus 3 greater than 0. Okay. So the consolidated output will be, and this validates for t plus 3 up to infinity. So the consolidated output y of t equal to 0 for t less than minus 3, and 1 minus e power minus 3 t plus 3 by 3 for t greater than minus 3. Okay. So this is the final output of the convolution between e power minus 3t and u of t plus 3, right? So let us solve some more problems here. So consider here x of t e power minus 4t and u of t minus u of t minus u of t minus 2, and h of t is e power minus 2t u of t, and this will be a finite duration sequence and this signal, and this will be right sided infinite duration signal. Okay, let us plot x and h. So x of t will be e power minus 4t multiplied with u of t minus u of t minus 2. So let's see first u of t minus u of t minus 2. So u of t will be like this, and u of t minus 2 will be like this. So subtract 1 and 1, you will get a pulse. You will get a pulse in the duration of 0 to 2, that is u of t minus u of t minus 2. This is that one. If this is multiplied with e power minus 4t, e power minus 4t is exponentially decaying signal. E power minus 4t. If this is multiplied with a pulse, like this 2, this is u of t minus u of t minus 2. The multiplication of these two, okay, gives to a signal like this. Okay, so here it's 0, so you will get the 0 at this position. Okay, and here it is 0, so you will get the signal in the duration of 0 to 2, that is a pulse multiplied with exponentially decaying signal represented by e power minus 4t. So the finally this is the signal of your x of t, that is e power minus 4t u of t minus u of t minus 2. So you convolute this x of t, this is multiplication. You find the convolution of this x of t and e power minus 2t. So let us find out the convolution for this is 2 convoluted with exponentially decaying signal, exponentially decaying signal e power minus 2t u of t, and this is e power minus 4t u of t minus u of t minus 2. So now I will fold this e power minus 2t u of t. Okay, so let it be this h, this is h of t and this is x of t. So let us convolve that one. So here I am time folding this one and shifting. Okay, so time folding I will get like this, and after adding t you will get like this. Okay, this will be h of t minus tau, that is e power minus 2 t minus tau u of t minus tau, and this will be multiplied with this one. Okay, this will be multiplied at different positions of t, x of tau. This will be multiplied with different positions of t. From tau minus infinity to plus infinity. So now the first case, this is like this and this is like this. Okay, x multiplied with h tau, this is 2, this is 0, x of tau, h of tau, multiplication. So in this position the product is 0, no overlap, that is y of t is 0 for t less than 0. Okay, next case, case 2, this t touches 0 and going in the region of 0 to 2. To 0 2, and this is y of t, that is okay, and this is the product y of t, x of tau multiplied with h of t minus tau, and this is given as y of t equal to integral. Here the overlapping is in the range of 0 to t only, t may be at the same position in the range of 0 to 2. Okay, you should not make the integral limits as 2 or any value. We have to make it as t. The t may be the value in the range of 0 to 2. Okay, t may be any of 0 to 2. Okay, so if you make it as integral upper limit as the 2, it will give a fixed value when t is 2, but you don't know the value when t equal to 1. So that's why simply make it the upper limit as t. So the product is e power minus, let me write minus 2 t minus tau, and another one is u of minus 4 tau. Let me write it as e power minus 4 tau. Okay, d tau. So let's solve this expression. So I'm bringing out e power minus 2t outside the integral 0 to t e power minus 2 tau d tau. Okay, minus 2 tau, sorry, plus 2 tau minus 4 tau, that will be e power minus 2 tau. So this is e power minus 2t e power minus 2 tau by minus 2. Substituting the limits, you will get the output as 1 by 2 e power minus 2t, and substituting 0 and making minus minus plus 1 minus e power minus 2t. Okay, and this is in the range of this validates up to t 0 to 2. Okay, this validates up to t in between 0 to 2 only. Okay, this validates between 0 to 2, that is y of t is 1 by 2 e power minus 2t 1 minus e power minus 2t. So you can multiply that both e power minus, let me rewrite it, e power minus 2t minus e power minus 4t. Okay, for the t in the range of 0 to 2. Okay. So if t crosses 2, that will be another case, and this expression doesn't valid for that one. So for the case 3, one is like this, the stationary signal, and another signal is that it crosses the 2, and this is t, this is 0. So now let us find the overlapping region that will be in the range of 0 to 2 only. The common area is in the limits of 0 to 2 only. So y of t will be so this is tau, this is y of t. Y of t will be integral 0 to 2. Okay, integral 0 to 2. One is e power minus 4 tau e power minus 2 t minus tau d tau, and this is by substituting the limits or bringing e power minus 2t outside integral 0 to 2. So minus 4 tau plus 2 tau e power minus 2 tau d tau, and this is e power minus 2t e power minus 2 tau by minus 2 0 to 2. So e power minus 2t e power minus 4 minus 1 by minus 2. So let me write this expression as e power minus 2t 1 minus e power minus 4 by 2, and this is for t greater than 2. Okay, after t cross, sorry, not less than, t greater than 2, after t crossing 2, the point, the value of 2, it will hold the expression as e power minus 2t 1 minus e power minus 4 by 2. So the consolidated output is y of t is, we have three cases, 0 for t less than 0, okay, here the no overlapping, t less than 0. In the second case, after t touching 0 and not crossing 2, t is the crossing 0 but not crossing 2. So in the range of 0 to 2, it holds another expression, this one, that is 1 by 2 e power minus 2t, 1 by 2 e power minus 2t minus e power minus 4t, and this is for t in between greater than 0 but less than 2. In the third case, e power minus 2t minus, sorry, 1 minus e power minus 4 by 2, and this is for t greater than 0. So these are the three different cases outputs hold for this problem. Okay, so these are some sample problems where you can find the convolution between two signals with ease by plotting the signals for each and every case. If you plot the signals properly for each and every case by mentioning the different ranges of t, you will get the proper output without any errors. Okay, so plotting of signals is important for the different ranges of t values. Okay, so I hope these points are clear for this session. So in the next lecture, let us solve some more problems considering two finite duration sequences. It may be pulse, it may be triangular waveform, or it may be finite duration triangles. Okay, let us solve those types of problems by considering finite duration sequences. Right. Thank you.